All right, welcome back to the deep dive. Today, we're doing something a little different. We are analyzing a single piece of hardware.
And it's just a cable.
Exactly, a DVI cable. But this isn't just any cable. We're looking at the PureLink PI4000-200 PureInstall, all 20 meters of it. And our mission really is to get to the why behind the engineering. I mean, why would a passive digital cable cost nearly $300?
Well, that why is almost entirely dictated by physics. 20 meters is just a monster run for a high-frequency video signal on copper.
So you're talking about signal degradation.
Exactly. Attenuation. The signal strength just falls off a cliff over that kind of distance. The whole challenge here is getting a clean signal from one end to the other without it just collapsing into noise.
Okay, so let's start with what it's actually designed to carry. It's a DVI single-link cable, right?
Yep. DVI-D male, 18+1 pin on both ends, strictly digital.
Which makes the signal a bit fragile, I'd imagine.
It is. So the goal here isn't, 4K or some cutting-edge spec. It's all about rock-solid reliability at its intended limit.
And that limit is 1920 by 1200, or WUXGA.
That's the one. And to hit that, it needs to support a maximum bandwidth of 165 megahertz. That translates to a transfer rate of about 3.72 gigabit per second. The entire build is just to make sure that ceiling is never, ever breached by interference.
And it still handles modern standards, too. Things like HDCP, CEC, deep color, 1080p, and so on.
Oh, absolutely.
Does something like HDCP, with its constant handshaking, put even more stress on the cable over 20 meters?
It does, 100%. Those complex data streams demand impeccable timing and extremely low jitter. This brings us right to the materials.
Exactly. If that's the performance you need to guarantee, what kind of brute force material science does it take? Let's talk about the copper first.
Okay, so the inner conductor is a high-purity tinned plated OFC copper, but the key spec is the thickness.
28 AWG.
Right, and you should think of AWG like plumbing a lower number means a thicker wire. So 28 AWG is relatively thick for a data cable.
And that lowers the resistance.
Precisely. That resistance saving is critical to keeping the signal strong across that entire 20-meter span.
Okay, so thicker copper. What about the protection? I saw this thing has intense triple-layer shielding.
Oh, 100% sealed.
We're talking aluminum foil, then another layer of aluminum foil, and then a braid on top of that. Is that overkill? Or is it really necessary?
Oh, it is absolutely necessary. You have to remember, DVI is an older transmission standard.
Right.
It lacks the robust built-in error correction that, say, modern HDMI often has.
So this triple shielding is basically its error correction.
In a way, yeah. The foil layers fight high-frequency interference, and the braid takes care of low-frequency interference.
Yeah.
It's the only thing standing between your WXGA signal and, well, absolute chaos.
And I assume that attention to detail extends to the connectors themselves.
It does. The contacts are 24-karat gold-plated, which is mostly a guarantee against corrosion. It ensures perfect conductivity over the, decade-plus lifespan you'd expect in a Pro install.
Now, here's the wrinkle I found. When I was looking at the product's features list, it mentioned some surprising things like high-speed HDMI for 3D and resolutions up to 4K. It even says it has an integrated Ethernet channel. But it's a DVI cable.
Yeah, that raises a bit of a flag, doesn't it? It's a classic case of marketing copy versus the actual specification. That language is almost certainly boilerplate text copied from the manufacturer's other, probably HDMI-centric product lines.
So it's a good lesson for anyone buying gear.
It's a great lesson. You have to trust the defined technical specs, the WXGA limit over the broad aspirational features copy.
And just to reinforce that professional claim, the product is TAA compliant.
Right. Which means it can be sold to the U.S. government or other specialized clients. It's been vetted. So our final thought is this. The investment in a cable like this, at that price point, it isn't about achieving some cutting-edge resolution.
No, it's about the assurance of quality, isn't it?
It's total assurance. The assurance that your 1920 by 1200 signal is guaranteed by the materials. That 28 AWG OFC copper and that intensive shielding to work flawlessly over a very, very challenging distance.
So what does this all mean, then?
Ah.
It leaves us with a provocative thought.
But
If passive copper technology is being pushed this far, requiring all this intense engineering just to reliably support WXGA over 20 meters.
what does that mean for 4K?
Exactly. What kind of specialized active technology? We're talking fiber optics, powered extenders. What's needed for stable, high bitrate 4K video over even greater distances?
We're really staring at the fundamental limits of physics and signal transmission here.
And that's something for you to mull over the next time you plan a major installation.